In this video, let's try to integrate sine inverse x whole square. To integrate this, we need to use one of the methods of integration. I'm going to use integration by parts. For integration by parts, we need two functions. So let's take the other function as 1. So the question can be written as sine inverse x whole square into 1 dx. The trick in integration by parts is to select the first function and second function carefully. First function should be the one which is easier to differentiate, and the second function should be easy to integrate. Let's take sine inverse x whole square as first function, that is f of x, and 1 as second function, that is g of x. We know that integration by parts says integration of two functions f of x into g of x can be calculated as first function into integration of second function minus integration of second function, that is g of x dx, into differentiation of first function and whole dx. So we can write integration of sine inverse x whole square dx as first function, which is sine inverse of x whole square, into integration of second function, which is 1. So I can simply write that as integration of dx minus integration of dx into f dash, that is d by dx of first function, which is sine inverse x whole square dx. To calculate further, I need to find values of two things. I need to find out value of integration of dx and then d by dx of sine inverse x whole square. So let's do that, but before that let's call this equation number 1. So integration of dx we know is x plus c. Let's call this equation 2. D by dx of sine inverse x whole square. So this can be calculated using the chain rule of differentiation, which simply says that we start differentiating from the outermost function and proceed inwards. So first we will find out sine inverse x whole square. So first we are going to differentiate this whole square. If we had t square, we could differentiate it as 2t. So for sine inverse x, I am going to write, for sine inverse x whole square, I am going to write it as 2 sine inverse x. Now I need to differentiate sine inverse x, which can be differentiated as 1 by square root of 1 minus x square. So I can write this as 2 sine inverse x upon square root of 1 minus x square and call this equation number 3. Now I can put equation number 2 and 3 in equation number 1 and I can calculate further. So putting 2 and 3 in 1, I get integration of sine inverse x whole square dx as sine inverse x whole square into integration of dx, which is x plus c. C we will add, this constant we will add later. So I am simply writing x minus integration of dx, which is x from equation 2, into d by dx of sine inverse x whole square. So this term, so that is 2 into sine inverse x upon square root of 1 minus x square and dx. We need to perform integration one more time. So we need to calculate integration of x into 2 sine inverse x upon square root of 1 minus x square. So I am going to call this whole term as I1 and calculate it separately, and before that I am going to call this equation number 4. So I1 I can rearrange these terms a little bit and write as sine inverse x into, let's take this minus also with us. So I am going to make this plus and write this minus here. So I get sine inverse x into minus 2x upon square root of 1 minus x square dx as I1. Here also I am going to integrate it by parts, since I see that two functions are in multiplication. First function I have to select the one which is easier to differentiate. So I am going to select sine inverse x as first function, and this term, the second function, will become gx. Let's put it in the formula and calculate. So I can write I1 as first function, that is sine inverse x, into integration of second function, which is minus 2x upon square root of 1 minus x square, minus integration of second function, which is minus 2x upon square root of 1 minus x square dx, into differentiation of first function, which is d by dx of sine inverse x whole dx. So let's call this equation 5. Now to calculate the integration of minus 2x upon square root of 1 minus x square, I am going to use another method of integration, which is integration by substitution. This is a very fun way to integrate. I am going to substitute a part of the function and get the rest by differentiating it. So I am going to take 1 minus x square as y. So this gives me minus 2x dx as dy. If I put these back, I get integration of dy upon square root of y. This can be calculated using the formula integration of y raised to n dx as x raised to n plus 1 upon n plus 1. Here n is minus 1 by 2. So I can modify this and write y raised to minus 1 by 2 dy. Using this identity, this can be written as y raised to minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. This gives me 2 into square root of 1 minus x square. And let's call this equation number 6. Next I need to find out d by dx of sine inverse x. So d by dx of sine inverse x can be calculated directly using the identity. So that is d by dx of sine inverse x is 1 upon square root of 1 minus x square. Let's call this equation number 7. Now we need to put 6 and 7 back into 5 and proceed further. So I'm just going to scroll it a little bit. So putting 6 and 7 in 5. So you get I1 as sine inverse x into integration of minus 2x upon square root of 1 minus x square, that is this. We have calculated it using 6 as 2 into square root of 1 minus x square, minus integration of 2 into square root of 1 minus x square into d by dx of sine inverse x, which is 1 upon square root of 1 minus x square and dx. Now we need to perform integration one more time. So I get 2 into sine inverse x into 1 minus x square minus, let's take this 2 outside, and here I have this term. So you can see one of them is in denominator and one of them is in numerator. So these two terms actually cancel each other and I'm left with only dx. So this we have already calculated. You can write this as 2 into sine inverse x into square root of 1 minus x square minus 2x plus c, and let's call this equation number 8. So now I finally have the value of I1 which I needed way back here in equation number 4. So let's put the value of I1 here and see what we are left with. So I can put 8 in 4 and get integration of sine inverse x whole square dx as sine inverse x whole square into x minus, we have changed it to plus, this I1. So I1 is 2 sine inverse x into square root of 1 minus x square minus 2x plus c, and this is the final answer. That is, integration of sine inverse x whole square dx is sine inverse x whole square into x minus 2 into sine inverse x into 1 square root of 1 minus x square minus 2x plus c. So you need to keep track of all the equations that you are substituting, and also you need to use more than one integration methods. So just go through this video one more time and I am sure that you are going to understand how we have arrived on this solution. Keep practicing. Let's meet in the next video.